Now let's create fire and let's explore some of these all of these options a bit further. And first, let me remove all of these top net and the top import field node. We don't need them. And let me rearrange this node graph in here. And maybe to create a fire, I'm going to create a separate source, and I'm going to create a geometry. I'm going to just create a rubber toy geometry in here. And let me view this and let's zoom in. I can press the F key in my viewport to frame my geometry. And now let's convert this geometry into volume. And you know that we can convert this into volume by using the VDB from polygons node. So maybe let's add this and let's uncheck this surface VDB and enable the fog VDB and lower down the voxel size. I'm going to load this down to maybe value of 0.01. And after that, let's create a pyro solver. And in here, we need to just connect this and onto the pyro solver. If I hit play, our source has been imported. But here as you can see, our resolution is not very high res, which means we need to go back and we need to lower down the voxel size. And we can ideally connect these parameter, this voxel size with our this sourcing voxel size, so that whenever we are going to control our voxel size, our simulation, we are creating the same resolution of our source as we have in the simulation. So to link these two parameters, I can select the parameter and right click, and in here we have this option copy parameter. I can say copy parameter, and let's select the node, let's say VDB from polygons node, and I want to control this parameter. So in here, I'm going to just select this and remove the value in here. And in here, I'm going to say right click, and in here, let's say paste relative reference. Let's click on it. And what that will do, it will create this channel expression. I can just click on it to see what the values has been evaluated. So which means I can just control the voxel size, this voxel size from here, which means if I were to lower down the voxel size 0.05, you know, this voxel size will going to be controlled as well. So these two parameter has been linked, and you should always link the voxel size with your source. Now let's me make this value, maybe let's keep this to at 0.05 and let's hit play. And you know, our source has been importing at every frame and we have this density accumulation. And right now, first this smoke is not rising. Let's say if I were to, that is going to be our smoke simulation, and it's not rising. And to actually make this simulation rise, we need the temperature. Temperature will cause the smoke to rise. Where we have the hot spot, the hot smoke will going to be rise. So we need to create another volume, because right now we are creating our this density volume, but in here we do not have the temperature volume. We can go into the sourcing. Here you can see we are importing the density volume and adding that into the density field of the top. And we also have the source volume temperature, and this source node is expecting this volume, and we are adding this into the top net because we do not have a temperature volume at the source. So the temperature field is empty, and thus our smoke is not rising. What I can do, I can create a temperature volume in here. So that the way that we can do that, I can just create another VDB from polygon node, or I can just duplicate this node. Just select that node and press and hold the Alt key and drag to duplicate this node. And for this one, I'm going to just rename this to temperature. So now we are creating a temperature fog volume. I just rename its name. Now if I were to middle mouse button, and here you can see we have this one VDB volume and its name is temperature. And now let's merge both of these volumes together by adding a merge node, and let's merge both of them. And let me connect this again, move this in here. And if I were to middle mouse button this merge node, we should see two VDB volumes, and here we have them, and we have these two volumes. And now onto the Pyro solver, we are importing the temperature inside of our top net. So which means if I were to hit play, and here you can see now, because we have the temperature volume, we have this heat information. Now all of this hot smoke is rising, and that is rising because of the buoyancy force. So wherever we have the temperature, our smoke is going to be lifted up by the buoyancy force, and I can control the buoyancy force by going on to this shape tab. And here as you can see, onto the shape we have all of these forces, and the very top we have the buoyancy force, and it's set to 1. And if I were to disable the buoyancy, let's say zero out the buoyancy, I can rewind and hit play, and here as you can see, our smoke is not rising. Even though we have the temperature field imported, our smoke is still not rising. That is because our buoyancy is 0, and I can change this to value, maybe let's change this to 0.1. So now our smoke is going to be lifted in a very slow-mo because we have very slow force of the buoyancy. And I can enable the buoyancy parameter, and in here we have the buoyancy scale, and we have the gravity and the gravity direction. So all of these hard fluids are tend to go the opposite direction of the gravity. So the gravity is set to -1, which means that gravity is pushing the smoke down on the y-axis, and we are getting our smoke upward. And if I were to change its direction to up, which means the 1, so now gravity is pulling the smoke up. Now we will see that our smoke will going to be rising down. So if I were to hit play, and here as you can see, our smoke is going on to the opposite direction of the gravity. And same way, if I want to buoyancy to be affect onto my this z-axis, which means I need to just change this z value to -1, because I want the smoke to rise into my positive z. So if I were to hit play, and here as you can see, our buoyancy is lifting onto the z-axis. I'm going to just default out this parameter by pressing and holding the control key and middle mouse button, and that will default out its parameter value. Let's hit rewind and hit play. Now we have this rising smoke effect. Let's increase the buoyancy scale to 1, and I'm going to collapse this menu so that we have these same default settings. And to actually import the fire, right now here as you can see, we are still working with the smoke simulation, and I cannot see the fire. And to create the fire, let's go into the sourcing. It requires the burn field, burn volume. Burn volume will be used to create the fire, and the burn volume is going to be added into the flame field of our DOP simulation, and flame field is responsible for creating the fire's flame. And we need to, which means we need to create another VDB volume. So I'm going to just duplicate this VDB from polygon node and merge this in here, and I'm going to just rename this to burn. So let's rename this burn, and now I should see fire. So let's go into the Pyro solver, and here as you can see, we have the fire. Let's hit play, and we are creating the flame, and I can also see the smoke. Here as you can see, into the whites. Let me adjust the look of my fire by going on to the Pyro solver and onto the look tab. And in here we have the density scale. Let's increase this, and maybe let's darken out my smoke color, and let's increase the density value again. And here as you can see, we have this smoke. We have the smoke and fire, and it's also rising. I can play around with the fire color to adjust the intensity of my fire. And in here as you can see, we are creating these separate VDBs for creating all of these volume. For density, we are creating another VDB from polygon node, and to create this volume. So to create all of these volume, we have these separate VDBs, but there is an actual workflow for creating all of these volume in a single node. And the way that we can do that, I'm going to just select all of this node graph and press and hold the Alt key and drag to duplicate. And this time I'm not going to use this workflow to create my volume, because every time I need another volume, I need to create another VDB and set the parameter. What I can do, I can create a node called Pyro Source. So if I were to add the Pyro Source node, let's add this, and I'm going to just connect this in here. And let me view this Pyro Source node. And what this Pyro Source node is doing, let me zoom in into my viewport. It's just extracting the points, and here as you can see we have these same points. These points has been extracted. So the Pyro Source is removing the primitives and just keeping the points. Let me bring up the parameter, and here as you can see we have this mode. It says keep input. Keep input mean that keep only the input of these points. In here we can change the mode. We can change this to surface scatter. So the surface scatter mean that we are going to scatter some points onto the surface of our geometry, and I can control how many points I like to scatter by playing around with the particle separation, which mean that the distance between particles. And if I were to lower down this particle separation, and here as you can see I am creating more and more points, and same way if I were to increase, I am creating less and less points. So that is the surface scatter method. And we also have the method to volume scatter, and what that will do, it will scatter point, it will fill out our geometry with these points. So we have all of the points onto our inside of our geometry as well to create a thicker volume. And most of the time we will going to be use the volume scatter because we need the thick source of our smoke or all of the volumes. You can change this to surface scatter to create a hollow volume, and this hollow volume will create a very thin flame or smoke. I'm going to just change this to volume scatter, and now we have these bunch of points. And onto the initialize, I can just initialize this. If I want to create the smoke simulation, I can say source smoke. Because I want to create a fire, I'm going to just click on this one, source burn. So let's click on it. And when you are going to select the burn, it will create these two attributes, the burn and the temperature. What this Pyro Source is doing, if I were to middle mouse button, it's just creating points and adding some attributes. We have the burn attribute and the temperature attribute, and we also have the P scale, the particle scale. And we know that particle scale is essential to set the scale in here. Next, I can just say VDB from particles. I can add a VDB from particles node and to convert these particles into volume. And in here I want to create a fog volume. So let's enable this. And in here I need to lower down the voxel size. Maybe let's lower this value down to 0.01. And here as you can see, we have this our volume pack. But in here we are still creating an A1 volume, density volume. But I would like to create multiple volumes. So we have another node called volume rasterize attribute. So let's add a volume rasterize attribute node, and let's add this. What this node will do, it will use the input attributes. Here as you can see, we have these two attributes. It will use these attributes and convert these attributes into different volumes. So which mean I'm going to just remove this and connect this in here. And onto the volume rasterize attributes, let me enable the parameter of this node. In here, we need to define the attributes that we want to convert into volume. So in here, I want to convert my burn field into volume, and here as you can see, I can see my volume. And if I were to middle mouse button, and here I have one VDB volume, and it is a density volume. And in here, I can select multiple attributes. So in here, I'm going to let's select a temperature. Let's select on it. And now we should see two volumes if I were to middle mouse button. And here as you can see, this node has been refreshed. It was saying that we have the density volume, but it's actually was the burn volume. And here you can see we have these two VDB volumes. One is called the burn, the same name that we have set it onto these attribute burn and temperature. It will converting them and assigning the same name to VDB volume, burn and temperature. I can even create multiple volumes. Let's say if I want to create a density volume, I can go into the pyro source node, and in here I can add other attributes by clicking on this option attributes. Let's click on this plus button, and in here I'm going to say any name that I like, but onto the attribute. Here we have some presets. Let's say I want to create a density attribute, and in here we should see these three attributes. If I were to middle mouse button, and here as you can see we have the burn, temperature, p scale, and our newly created density attribute. And if I were to convert this into volume again, I just need to go into the attributes, and in here let's select our density attribute as well. And now if I were to middle mouse button, and here as you can see now we have three VDB volumes, burn, temperature, and it's still saying temperature. Now it's saying density, which means we always need to just refresh this. And if I were to middle mouse button, burn, density and temperature, these three volumes. And it is a much easier way to convert your attributes into volume by using this simple and a single node. And before that, here as you can see we are creating these three nodes, and now we can use just one node to convert all of these attributes into volume. And now I can go into the pyro solver, and we should see the same effect if I were to hit play. And here as you can see we have imported all of our fields into the sourcing, density, temperature and burn, and all of these three volumes are going to be imported to create this fire simulation. In here I can adjust some parameter. Let's say if my temperature is rising fast, I can, in here we have this method acceleration strength, and that is because its operation is set to pull, or I can change this to add. We have this different type of operation, and in here by using the add I can say that all of the volume should going to be added every frame, or I can change this to 0.1, which means that I want the 0.1% of for this incoming volume should be imported in here into this top, which means we are adding less heat in here, and we should see the slow rising of our flame. And if I were to hit play, and here as you can see I think the 0.1 value is still too high. I can lower this value down to 0.01, and now and here as you can see we have a very slow rising of this fire because we have lot less heat. And same thing in here, if I want to create less flame, I can increase this source scale. This is actually just a multiplier. So I'm going to just change this to 0.1. Let's go back and hit play, and here as you can see we have less flame but we have more smoke, and that is because density represents the smoke and we are adding more density, which means we are creating more smoke and less flame. And to actually apply forces, let me go back and maybe let's change its flame field to 1 to the value of default. And in here I'm going to just change this value to 0.1, and I think that this rising looks fine. And in here I can go into the shape tab and I can enable the disturbance and turbulence, and let's hit rewind and hit play, and we should be able to see some breakups, and maybe we need to increase its value. I'm going to change this to all the way up to 1, and let's hit play. And I'm still not seeing much effect, so maybe let's increase this value. And here as you can see I can really start to see this force kicking up, and here as you can see this bounding box is increasing as this fire is increasing. I can go into the bounds tab. Here we have the bounds. Here we can limit this domain size if I were to enable the limit. And in here I'm saying that you are allowed to onto these 10 units. So our bounding box will grow onto the 10 units only. So if I were to hit play, and as you can see this domain is growing, but after the 10 unit it's going to stop growing and this fire simulation is going to be cut off. And I can confirm. As you can see, when we have reached these bounds limit, this simulation is cutting off at the top. And what I can do, I can say that after we have reached these bounds, I want these bounds to not cut off my geometry but act as a collider. So which means this simulation will not going to be cut off, but they are going to be colliding with these walls of these bounds. So I can do that by going on to the collisions, and here we have the option for the ground planes. So let's enable this, and here as you can see we have the X, Y and Z ground plane. So these ground planes represent these bounds. So right now here you can see this Y, this one is cutting off. I can say Y ground, please say close above. So which means that close above 0, this container will act as a ground plane. Let's go back and hit play, and I can adjust its value to increase to match these bounds. I can in here maybe let's increase its value to 3. Let's go back and hit play, and with the unit of 3 we will start to see some collision effect. And here you can see, if I were to check, you will see that simulation is not cutting off, but it's actually colliding with the walls of these bounds. There we have these ground planes, and in most cases we want to add the ground plane below Y because that grid is our ground. So in here you are going to say closed below, and I want to change this to 0. So which means that below 0, which means that below this ground, this grid, we have the ground plane, we have this ground. So let's hit play, and here you can see we have some collision happening in here. Most of the time we are going to add the ground plane like so. Maybe let's explore some other option of this Pyro solver, and let's explore them in the next lesson.